This is a brief video just explaining how the unit circle relationship exists and how it links to trigonometry. You might remember from a previous math class the rule SOHCAHTOA, and that stands for sine of an angle is the opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent. And that rule applied to right triangles. So if you had a right triangle and if you had, say, an angle here, we're going to use that theta symbol for the angle instead of A or B or C, just because we're going to link that to the unit circle. The opposite is always across from the angle, so we call that the opposite. The adjacent is the side that's next to the angle that's not the hypotenuse. So I just abbreviated ADJ, and then the hypotenuse is the longest side of a right triangle. We'll use sine and cosine today to kind of link it to the unit circle. First, what is the unit circle? Basically, it's a circle that's centered around the origin of an xy axis, and it has a radius of 1. And so if that radius is 1, then I should be able to figure out, if I know a little bit about trigonometry, given any degree. Can you please call the front office? Coach Skinner, please call the front office. Given any degree, what is a specific coordinate of that unit circle? So typically, how we navigate around the unit circle is we go by 15 or 30 degree increments. We can get some special coordinates along that unit circle that we're going to have to eventually know. So what I'm going to do is I'm going to try to figure out what that xy coordinate is. But first, just a little bit of visual how that links to sine, cosine, and not really so much tangent, but sine and cosine. If you take a right triangle, so if you take that point on the unit circle and you extend it down to the x-axis so that it makes a right angle, then it turns out that the x value of that angle, the length between the origin and this point right here, is that part of the coordinate, and the y value, the vertical distance, is that part of the coordinate. And if you remember anything about the SOHCAHTOA rules, the sine, well, let's start with cosine first. The cosine of an angle, we'll call it that theta symbol again, is always going to be the adjacent over the hypotenuse. Well, in the unit circle, the radius here is 1. So that hypotenuse is always going to be 1. So if we modify it a little bit just for this, the cosine of the angle is always just going to be the adjacent over 1, which is simply just the adjacent leg. Well, that's the x-coordinate. So in the unit circle, the x-coordinate is just the cosine. Similarly, the sine of the angle is the opposite over the hypotenuse. So if I look at that relationship, same angle. Again, the hypotenuse, since that radius is 1, the hypotenuse is just 1. The sine of the angle is going to be the opposite, which means the sine of the angle is going to be the y value. So the cosine is going to be the x, and the sine is going to be the y. So those are two important pieces of information that are going to help us navigate around this unit circle. Now, y'all are going to get a copy of this blank unit circle. And this is going to help us kind of figure out, how do I get the degrees? How do I get the coordinates? And eventually, what are the radian measures going to be? And we talked about how to convert from degree to radians, so we'll review that as well. So Quick little bit of refresher on the quadrants. You know, this is quadrant 1. This is quadrant 2. If we count counterclockwise down here in the bottom left, quadrant 3 and quadrant 4. So you do got to kind of know those quadrants, and you also have to know the sign of the number here. So in quadrant 1, both the x and the y are going to be positives. In quadrant 2, the x is negative, but the y is positive because you're going up. In quadrant 3, they're both negative. And in quadrant 4, the x is positive, but the y is negative. So we have to know those relationships. Let me zoom out a little bit so you can see. Now the degree measures around around any circle. There's always 360 degrees. So remember that the terminal side of the angle is where it opens to. It always starts at 0 degrees. That's your degree symbol. If we're going up here, that's 30 degrees into the circle. So I'm first going to count by 30s. You'll notice that this degree is a little bit closer than 0 to 30. So I'm going to skip it, and we're just going to keep adding 30 around the circle. All of these angles here, this first one and the third one, and the one up here is going to be another 30. That's 90 degrees. So we got 30, 60, 90. And if we continue that pattern, all the big wedges, so this wedge here, this wedge, those are each going to be 30 additional degrees. So this will be 120 degrees. I skip over that little one, 150. 15 plus 3 is 18, so 180. You should recognize 180, that's half the circle. Keep that pattern going. 18 plus 3 is 21, so 210. Skip over the little one. 21 plus 3 is 24, 240. Down here at the bottom, that's 270. And you probably recognize 270 as well. And keep that going. 300, 330, and eventually, if you did it right, you get to 360. Well, we can also get the degrees in between them too. This is halfway between 60 and 30. So if I'm counting up 30 to get from 0 to 30, then this is only going to be 15. So 30 plus 15 is 45. 45 plus 15 is 60. Same over here. 120 plus 15 is 135. And 135 plus 15 is 150. 210 plus 15 is 225. And 300 plus 15 is 315. So we can get all the degrees by doing either multiples of 30 or adding 15 in between those. The coordinates we can also get as well. We can at least get the coordinates out here on the right, the top, the left, and the bottom, because the radius, remember, of the unit circle is 1. So if the radius is 1, then this is going to go right 1, but it's not going to go up or down, so that's going to be a 0. Up here, it goes up 1, but it doesn't go left to right. So that's going to be 0, 1. Over here, it's going left 1 and not up or down. So it's going to be -1, but 0. And finally down here, it's going down 1, but not left or right. So it's going to be 0, -1. And if you look at the numbers, these should be opposites because it's 180 degrees. And these should be opposites because it's 180 degrees. The coordinates will, let me show you a little bit on the calculator to kind of explain what's going on with those. So if you remember me saying this, the x value is the cosine, and the y value equals the sine. So the way that the coordinates work is, I'm going to show you using the calculator. If you take your TI-84 and you press the mode button and change it over to degree, okay, we're going to be working in degrees, not radians for the time being. You can press clear to get out of that menu and get back to the home screen. if I want to know the x value here, and I'm going to say, all right, what's cosine of 30 degrees? Well, it's telling me it's 0.866. I don't want to write a decimal for that. I want an exact answer. It turns out through properties of special right triangles that that's exactly the square root of 3 divided by 2. If I do the sine of 30, so I want to know the y value at that 30-degree angle, that's 0.5. Well, 0.5 is 1/2. You can't convert a decimal that doesn't have a pattern to a fraction, so we have to know that's the square root of 3 over 2. 45 degrees, again through properties of special right triangles, it turns out if I do cosine of 45, that's about 0.707. It ends up being the square root of 2 divided by 2. And because this coordinate is halfway between 0 and 90, it's going to follow that the sine of 45 is the same number. So that's also going to be the square root of 2 over 2. And if I go to 60 degrees, the cosine of 60, that's 0.5. Well, that's 1/2. And then the sine of 60, the y value, is 0.866. And if you remember, let me scroll up here because we did 0.866. That was also the square root of 3 over 2. Now I want you to look at the pattern. These two numbers are the same. These two coordinates are just reversed, x and y. So all you really got to remember is, three values: 1/2, the square root of 3 over 2, and the square root of 2 over 2, and where they fall in the circle. And then if I do a little bit of, I can show you the other coordinates are going to be similar, but the sign's going to change. So if I go over here, if I want to know the 120 degrees, again, I can do cosine of 120. And that is negative 0.5, so that's going to be negative 1/2. And I can do sine of 120, press tan, sine of 120. That's going to be positive 0.866, which is the square root of 3 over 2. Well, this point right here has it's at the same point above the x-axis, so it's going to have the same y value. But because it's on the other side of the x-axis, the x value, or the y-axis, the x value is going to be reflected. It's going to be opposite. So if you look at that pattern, you're welcome to type these all in, but this coordinate here, it should have the same y value because y is positive, but the x value should be negative, so this should be negative square root of 2 over 2. And with 150 degrees, the y value should be positive, 1/2. And the x value is going to be the opposite of that, so the square root of 3 over 2. And I'll just check that real quick. I'll do 150. If I do cosine of 150, that's negative 0.866, negative square root of 3 over 2. And if I do sine of 150, that's positive 0.5. And again, we can get those coordinates down here as well. We can look at kind of the opposites from quadrant 2 to quadrant 3. These are both going to be negative. So if I'm looking at this coordinate and kind of reflecting it, we're going to find that it's going to be negative square root of 3 over 2 and negative 1/2. Negative square root of 2 over 2, and also negative square root of 2 over 2. So those are going to be the same coordinates again. And then down here, both of these are going to be negative, negative 1/2 and negative square root of 3 over 2. And I can test that with one of them. I'll do 210. Cosine of 210, negative 0.866, which is the square root of 3 over 2, and sine of 210, negative 0.5, negative 1/2. And while we're at it, we could even do 180. We could do cosine of 180, negative 1, sine of 180, 0. So we can even get the coordinates up here if you really could remember them. Down here, we got 270. So going over to 300, kind of continuing that pattern, on the quadrant 4, the x value is going to be positive and the y value is negative. So if I go over to here, I should expect that 1/2 to be positive, and the square root of 3 the square root of 3 over 2 to stay negative, but that x value's got to be positive. Same way in the middle, positive square root of 2 over 2 and negative square root of 2 over 2. Positive, negative. And finally, the last coordinate, 330, positive square root of 3 over 2, that's coming from here. Flip that sign, it's positive square root of 3 over 2, and negative 1/2. And if we did that right, these y values should be flipped as well from here. So these should be coordinating the middle ones and the ones at the end. So those are all the degrees and the coordinates around a unit circle. And we can also get the radians. That's where this last blank comes in. Remember, the other day we converted a degree to radian. And to do that, we can take the degree and multiply by pi divided by 180. But we don't type the pi in our calculator. So what I'm really going to do to get that radian, 0 degrees, well, 0 divided by 180, that's 0. So this is really 0 pi. And 0 pi is 0. So that's 0 radians, 0 pi radians. 30 degrees, we're going to do 30 divided by 180. And we don't want to write a decimal. So we're going to do math enter, enter. And we're going to get a reduced fraction. That's going to be 1/6. And then we're just going to write a pi next to it, 1/6 pi. And same thing with 45. 45 divided by 180. Math enter, enter. 1/4 pi. Or pi divided by 4 if you don't want that 1 up there. And we can do that for all the degrees to convert to a radian. 60 divided by 180. Math enter, enter. 1/3 pi. 90 divided by 180. 90 is half of 180, so that should be 0.5 pi or 1/2 pi. Continuing that, we'll go through all of them. Pause it if you want to try it on your own and get the rest of them, and then you can check it with me. 120 divided by 180 is 2/3 pi. Also, we can write it as 2 pi over 3. That's another way to write it. In any of these, you can put the pi on top of it. 135. That's 0.75. That's 3/4 pi. 150. 5/6 pi. And finally, 180. 180 is half. So 180 divided by 180 is half of the circle, but 180 divided by 180 is 1. So that's going to be 1 pi. And we don't have to write the 1, we just write pi. So remember, around a circle is 360 degrees. That's also going to be 2 pi radians. Because if I do 360 divided by pi, or 360 divided by 180, excuse me, that's 2. And remember, the formula for circumference is 2 pi r. But the radius is 1, so 2 pi times 1 is 2 pi. So essentially, that's the circumference of the circle, given that the radius is 1 unit. Let's fill in the rest of these radians using the degrees. So 210 divided by 180 is 7/6 pi. I'll do this a little faster. 5/4. 240. 4/3. 3/2. 3 pi over 2. 300. 5/3 pi. 315. And that is our unit circle. A lot of math teachers require you to memorize the unit circle. What I really suggest you do is, have a blank copy of this. Learn how to count the degrees. You don't have to memorize the degrees. It's just going around the circle. If you know the pattern, you can get those degrees by just adding 30 or 15. You have to know that cosine is x and sine is y. So really, if you knew that the square root of 2 over 2 is 0.707, and if you knew the square root of 3 over 2 is about 0.866, you could get away with doing the cosine of the degree and the sine of the degree and getting those decimals. And depending on the sign of those decimals will determine where they fall and which quadrant they go in. And then if you know that the degree divided by 180, when you make that a fraction, if you write that next to pi, you can get all the radians. So it's not as much memorization as it is just a tool to be able to get you around the circle. And ultimately, we need these degrees, we need these coordinates and radians to be able to solve problems. And this unit circle really will come in handy. So my advice is try to take a blank copy of this unit circle. You can ask me for an extra one if you need to. And practice filling it out on your own until you're able to do it without looking on this video, without looking it up, and without looking for help. If you can do that, you can use this on any quiz or test we take. And that's going to help you solve a lot of problems. Hope that was helpful, and thanks for watching.